Right. Okay. I just noticed that the time down there says 2003 January the 1st. Now ignore that particular time on the computer here, because the issue there is that the PC being used here has a flat battery on its motherboard, so every time it gets turned off it resets itself, and it's not connected to the internet to reset it. So for the sake of form, I would just point out that in fact we are the 5th of December 2013, and it is exactly 15:02, so it's at 3 o'clock in the afternoon. So we were just debating, while we had to wait for the battery to recharge itself a little bit, whether in fact what's happening here with these relatively low number of meteors at the moment. We've had one meteor while the battery was flat, so looking at the timing there, it's 16.5 minutes, so in fact we have seen something like 4 or 5 meteors, of which 2 to 3 were reasonable size and 2 to 3 were of just tiny little blips. So that certainly seems a lot less than the sort of quoted averages online of...
There's one. Look at that.
Oh, look, that's a big one. That's the biggest one that we've seen so far.
And one next to it.
And one next to it. No, this is good, because this shows all the features. You've got the spike that occurs there, and interestingly, up on the blue line, you've actually got this white dot that appears as well. Oh, that is definitely the biggest one that we've seen so far this afternoon. So this is proving that the aerial works well. It proves that the frequency of 143.049 megahertz upper sideband is working well. Just to reiterate on the WS JT 9.3 program, the settings. Yep. So I just get there a little video of the aerial in action. So there we are. That's the new quad antenna on 10 foot, and you can see at the background it's Big Brother. Just point out, for the sake of this video, the Big Brother is not actually being used at the moment. It's just there. This is that's Bill's normal aerial for
a tri-bander for 2, 4 and 6 metres.
I think he communicates with Mars on that, actually. It's so big. Right, now looking back here on the settings, it's just worth saying the settings we've got here is that auto is off. When auto is on this program, that's actually for automatic transmission every 30 seconds as part of meteor scatter radio transmission attempts. In addition, what else have we got? It's on W8 WN space G4EHT, which is actually the transmission code where the auto on being used.
You would select those if you was talking to anybody.
Yeah, so not really relevant for what we're at the moment. It's worth saying that we're on monitor at the moment, as you can see. So probably most of the other settings are not really relevant as far as today is concerned. Let's see if we can pick another one up while we're about it.
That was a beauty, though. That
was very good.
A little one next to it, wasn't it?
Yeah. So, but it just shows the sort of frequency that we're expecting here. Say 5, perhaps 6, 7 in 18 minutes so far. So, in fact, you could say that the average is about 1 every 3 minutes. Yeah. And you were commenting that in the morning you seem to be getting a much higher rate.
In the morning,
and certainly when it comes to meteor showers, they do say you're supposed to get a lot more after midnight, up until early morning. It's supposed to be something to do with the effect of, like when you've got a car driving along, and you're being rained on, you get more rain on the front windscreen than you do on the back.
It did that as a decode. It's meaningless, but it actually decoded that.
That's right, because this is a program that's designed
for meteor
scatter radio transmission reception.
And information transmitted by 2 stations. But that would be an indication of the strength of it and the width of the signal.
Right, so it's actually saying the width of the signal there is on that big one was 40.
That is.
Yeah, with 1 decibel.
And the report 16.
Right.
Yeah.
Again, whatever that means.
Yeah, well, I mean, you can find out what the DF is. Normally, DF is direction finding, but it means something else, Andre.
Yeah.
Yeah.
So bear in mind, it says receiving down there in the corner, and up here that we're on 0 decibels. So again, we're still only about 7 or 8 meteors, and that's in 20 minutes.
Yeah.
So again, it's giving us an idea of the sort of frequency you expect in the afternoon. It'll be very interesting on this day, yeah. It'll be very interesting to see how much that varies. And of course, the whole idea of this at the moment is to try and get us all set up in action for the 13th and 14th of December.
I bet them dates there'd be a lot more.
Yeah, well, that's the Geminid meteor shower, so it's one of the big meteor showers of the year.
Is it really?
Yeah, I mean, observation, it's supposed to be awful this year because there's a big full moon at the same time, so it's going to be terrible. But that shouldn't affect radio detection. So
no.
And of course, this is.
Well, it's still beaming in the right direction. That's one good thing.
So this is detecting it from Graves meteor station. Graves radar station. Sorry, which is in Dijon in France, and they broadcast on the 143.049 megahertz. What I don't know is whether if we could vary that slightly on a few kilohertz, whether it might in fact pick up more meteors. I mean, it's only going to kilohertz here, literally. Well, I'm trying to remember what's. I think the guys were saying up a bit actually. Probably 049.26 was quoted by somebody.
Well, we'll go on 26 then.
I think the signal that comes out of Dijon is actually 0.49 spot on.
There you go. 0.26 we're on.
But there's some modification of it in the 1,000 odd kilometres between here and there.
Yeah.
I mean, what I am interested in is that when you actually go onto the Norman Lockyer Observatory's site and you actually see that the ones they've got from all around the country, there seems to be different numbers of meteors being picked up in different locations. That doesn't quite make sense to me. But if they're all picking them up from the same broadcast signal.
Well, the only thing that is going to affect it is that was a tiny one,
So again, so this is demonstrated already that if you vary the frequency,
tiny one
frequency, you can still pick meteors up. So there must be being some variation, perhaps from the reflection off the meteor, might affect the frequency a little bit to get back. So it might be that we need to play around with those frequencies a little bit, of a few kilohertz, to see where we get the maximum frequency. I'm just thinking about that question about whether different locations could pick them up.
Well, everybody's aerial's going to affect it, isn't it, straight away?
That's a good point. Different aerials.
Height is important.
How much?
I mean, we're talking about line of sight anyway, aren't we?
That's right.
Theoretically, I should do better here than you do down where you are.
Because you're higher up.
Because I'm more elevated.
That's okay, as long as it just means that you do better and not that you're the only one that can get it and I can't. Which is my big worry.
I tell you what, you'll be annoyed if you don't.
I will be, but I mean, we've proven here we've got the right aerial now.
Oh yeah.
Yes, thanks very much, Bill. That's fantastic. It's clearly a much better aerial than the one that I've got.
Well, I am going to do. In fact, I'm going to do it now. I've got it here. What you can't see, can't lie.
Are you going to test the aerial?
I'm going to show you,
Yeah, very good.
Put the analyzer.